In today's class, we are going to look at some examples of what we discussed in the previous class, and also we are going to discuss the resistance of system of resistors. So first, which of the following represent an ohmic conductor? So A, and B. Okay, so A, whenever we know that V is directly proportional to I, for a directly proportional equation we always have a straight line that passes through the origin. So whenever we have a straight line for V versus I, we say that it's an ohmic conductor. So V is directly proportional to I. So in such case we should have V and I, that should be a straight line. So here we have a straight line. So A is an ohmic conductor. And whenever we have a curved line, we say that this is a non-ohmic conductor. Ohmic conductor is basically one which follows Ohm's law, and non-ohmic conductor is one that does not follow Ohm's law. So if we have a curved line, then V is not directly proportional to I. This does not hold. As this does not hold, then this is not an ohmic conductor. So this is a non-ohmic conductor. For A, we have an ohmic conductor. Okay. Now we'll look at some examples relating the things that we have discussed. For resistance, this formula, and R, V equals to IR, R equals to VI, all these formulas. Okay, so A, how much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohm. Part B, how much current will an electric heater coil draw from a 220 volt source if the resistance of the heater coil is 100 ohm. Solution. Okay, so how much current will an electric bulb draw from a 220 volt source? So our voltage or the potential is 220 volt and the resistance offered is 1200 ohm. So for part A, given we have potential difference V equals to 220 volt, resistance equals to 200 ohm. So we know V is equals to IR. From here we get I equals to V by R. So this implies I equals to V is 220 by R is 1200. So 0 0 cancels off, 211 to 60. So 11 by 60, decimal comes 0. So 6160 minus 50, because of the decimal another 0. 6 into 8, we have 480 minus 20, 0. 6, 3 is a 18, 20. So this we have, this implies I equals to 0. See, the third decimal, when we round it off, since this is less than 5, so it will remain 8. If it were to be greater than 5, we would have increased 8 by 1. So this will remain 0.18, and the unit for current will become ampere. As both are in SI unit, so the current will also be in SI unit, that is ampere. For part B, how much current will an electric heater coil draw from a 220 volt source if the resistance of the heater coil is 100 ohm? So now in this part we are given voltage is 220 volt, and in general house supply you can also remember that the voltage is generally 220 volt itself. In question you may be given different, but generally you will find that it will be 220 volt, and the resistance now given to us is 100 ohm. So this implies I equals to V by R, which is equals to 220 by 100, that is 2.200 cancels off, 22 by 10 is 2.2 ampere. So this is our current draw. Okay, next example. The potential difference between the terminals of an electric heater is 60 volt when it draws a current of 4 ampere from the source. What current will the heater draw if the potential difference is increased to 120 volt. Okay, the thing to understand over here is that V is directly proportional to I. So what changes when we have three things: potential difference, the current and the resistance. So potential difference is changing, current, as the potential difference changes, the current will change. And the third thing, resistance, depend upon the material of the wire. Here we have the same electric heater. The electric heater is not changing. So if the electric heater is not changing, its length, the length of the wire, all things are remaining same. So the resistance will remain constant. So we need to find out what remains constant. So first of all, we'll write given V1 equals to 60 volt, I1 equals to 4 ampere. So therefore resistance V equals to IR, R equals to V by I. So the resistance is going to remain constant, so we are finding the resistance. So this is 15 ohm. So resistance is going to remain constant. Now we have V2, the potential difference, as 120 volt, and the resistance is going to remain the same, that is 15 ohm. So V equals to IR, we know, V equals to IR. So from here we have I equals to V by R. So this implies V2 equals to I2R. So I2 equals to V2 by R. V2 is 120 by R is 15. So we have 15 into 9 is 15 into 8 is 120. So this implies I2 equals to 8 ampere. So when we change the potential difference to 120 volt, what happens is the current changes to 8 ampere. So the current through the heater becomes 8 ampere. Or we can also do this in another way. We know, okay, first of all we'll write given V equals to V1 equals to 60 volt, R1 equals, I1 equals to 4 ampere, V2 is 120 volt, I2 equals to question mark. So we know V is directly proportional to I. So this means V1 directly proportional. So we'll have I1 in the numerator by V2 equals to I1 by I2. So V1 by V2 equals to I1 by I2 because directly proportional is there. So we'll have this in the numerators and the denominators, say 1 1 then 2 2 in the same numerator and in the denominator. So V1 we have 60 by V2 120, I1 4 by I2 question mark. So I2 comes over here, 61 sir, 62 sir. So I2 equals to 4 into 2 which is equals to 8 ampere. We can do in this way as well because we know that V is directly proportional to I and the resistance is not changing. So for constant resistance we can use V directly proportional to I as well. Okay. Next example. Resistance of a metal wire of length 1 meter is 26 ohm at 20 degree centigrade. If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal at that temperature? Question mark. So solution, so we have, that is given to us, the length of the wire, that is L, is 1 meter. The resistance of the wire R equals to 26 ohm. Diameter D equals to 0.3 mm. So first of all we'll convert this millimeter into meter. We will use the SI unit for all of them. So diameter will write as 0.3 into 10 to the power minus 3 meter. Milli is 10 to the power minus 3. So this implies radius equals to diameter by 2, which is equals to 0.3 into 10 to the power minus 3 by 2 meters, which is equals to 3 by 2 into 10 to the power minus 3. When we remove the decimal, we have a 10 in the denominator. So 3 by 2 into 10 to the power minus 4 meter. So this implies area equals to pi r square. Since a wire is circular, the cylindrical, so the cross section is circular. So this will be pi r square. So pi will take the value as 22 by 7. Into the radius of this is 3 by 2 into 10 to the power minus 4 whole square. Now R is rho L by A. We know this one. We discussed in the previous class with the resistance of a wire. The formula is R equals to rho L by A. So we have the value of R, we have the value of L, we have the value of area. So we need to find the value of resistivity. So this implies rho, this rho will be equals to R into A divided by L. So this is equals to, this implies rho equals to R is 26 into area is 22 by 7 into 3 by 2 into 10 to the power minus 4 into 3 by 2 into 10 to the power minus 4 by the length of the wire is 1 meter. So 2 ones are 230, 2 ones are 211. So we cannot cancel 7 with any of them. So let's solve this. 339, 13 into 9 is 117 into 11. So 117, 117, we have 1287. So this we need to divide by 7. So on dividing by 7, we get 7 ones are 7. We have 5 in hand, 58, 7, 6, 7, 8s are 56. We have 2 in hand, 27, 7, 3s are 21. We have 6 in hand, we'll put a decimal, we get 60. 7, 8s are 56. We have 4 in hand, a 0 because of a decimal. So 7, 5s are 35. We have 5 in hand. This keeps on going. So we'll just stop over here and into 10 to the power minus 4 into 10 to the power minus 4 is 10 to the power minus 8. So we get, if we shift 2 decimal to the left, 1.8385 into, so we'll multiply this by 10 square because we are shifting left, means we'll multiply by 10. If we shift to the right, we need to divide by that number of tens. So we are shifting 2 decimal to the left. So 10 to the power 2 into 10 to the power minus 8. So we'll round it off. So third decimal is more than 5. So we'll have 1.84 because on rounding off we'll get over here 1 more, that will be 4 into 10 to the power minus 6. And the unit for resistivity is ohm meter. So this is our resistivity. So therefore, the resistivity of the metal, since the resistivity changes with temperature, we need to mention that it is the resistivity at 20 degrees centigrade is 1.84 into 10 to the power minus 6 ohm meter. This is how we find the resistivity for a given wire. Next question. A wire of given material having length L and cross section A has a resistance of 4 ohm. What would be the resistance of another wire of the same material of length L by 2? We are decreasing the length to half the initial length, and area of cross section 2A and we are doubling the area. Okay. So solution. Okay. First of all, let's understand the concept. So say we have this length of the wire as L and the area, this round thing, as A. So what we are doing is we are doubling the area and decreasing the length to half. So this one will get fatter, the area is increased. So this is 2A, double the area, and length is reduced to half. So we know that the resistance is directly proportional to the length. So if we decrease the length, what happens is the resistance also decreases. And resistance is inversely proportional to area. So if we increase the area, so resistance will again decrease. So overall we see that the resistance should decrease. Now let's find out what the resistance will become. This is just the understanding of what is happening over here. Okay. So the initial resistance that is given to us is 4 ohm, for which we have the initial length as L, the initial area as A. The final resistance we need to calculate. The final length is half, that is L by 2, and the final area is increased to double the initial area. We know R1 will be equals to rho L1 by A1. So this implies 4 equals to rho L by A, which implies 4A by L equals to rho. So we have the value of rho, and we know R2 will be equals to rho L2 by A2. The rho value will not change because rho depends upon the material, and we are talking about the same material, so rho does not change. Whereas the resistance will change since we are changing the length and the area. So this implies R2 we need to find out equals to rho we can replace as 4A by L. Let's mark this as 1. So we say using 1. And the value of L2 is L by 2 and the value of A2 is 2A. So this is equals to 4A by L into L by 2 comes down, so 4A, A cancel, 4 cancel, L cancel. So we have 1 ohm. So therefore the new resistance is 1 ohm. So therefore resistance of new wire is 1 ohm. Okay, let's look at another method of solving this same question. Say, we know R. Okay, first of all, let's write what is given to us. So, given R1 equals to 4 ohm, L1 equals to L, A1 equals to A, R2 equals to question mark, L2 equals to L by 2 and A2 equals to 2A. Okay, so resistivity is going to be same. We know that resistance is proportional to L by A. So this implies R1 by R2. Resistance is directly proportional to length, so L1 by L2, and inversely proportional to the area. So inversely proportional means if R1 is in the numerator on one side, then the area 1 will come in the denominator and R2 in the denominator, so area will come in the numerator. So this implies R1 is 4 by R2 is, we do not know, we need to find. L1 is L, L2 is L by 2, into A2 is 2A by A1 is A. So here AA cancels off, LL cancels off. So 4 by R2 equals to 2 goes to the numerator, 2 into 2 we have 4, which implies 4 by this 4 comes down equals to R2 1. So we have R2 equals to 1 ohm. So we can do it in this way or in this way, whichever you find comfortable and more understanding, you can do in either of the way. Both ways are correct. Okay, now we'll discuss the resistance of a system of resistors. So this one is one of a very important topic in the chapter. So please be very careful while understanding this one. So first of all, we are going to understand resistors in series. Okay. We have a battery, a key K, an ampere, or ammeter to measure the current. We have, say, 3 resistances. Resistance is caused by different, say, appliances. Like, say, this is a bulb. The another one we say is a fan. And the third one, let's see, it's some other appliances like say mobile charger. So we have 3 appliances measuring R1 resistance, R2 resistance and R3 resistance. Okay, and very important to note that, so as current is passing over here, say current I is passing, so there is only one wire that is over here all throughout. So what is happening is this current doesn't split. So the current remains constant in the whole circuit. So I is constant. This is an important point. I is constant throughout the circuit. So what is going to change is the potential. So V will be different. So whenever we have resistance in series, will be different for different resistors. These appliances that we use, we call this as resistors. Okay, so and the total voltage that is there, say the voltage is V. So V will be equals to the voltage across this is say V1, the voltage across this is say V2 and the voltage across the third one say is V3. So these are the 3 voltages across the 3 points. So 3 resistors have V1, V2 and V3. So the total voltage V that is going to be will be equals to V1 plus V2 plus V3. So this will be the total voltage. Current is going to be constant for each of the resistors. The current is going to be I because there is no splitting in current. So the current remains I itself. Now we know that V equals to IR. So the whole voltage V will be equals to I, the whole voltage, that is I into R. R will be the total resistance in series. For the first one, the voltage will be equals to I, that is the current passing through the first resistor, into R1, the resistance of the first resistor, plus V2 is equals to I into R2 plus I into R3. So this implies I Rs equals to, I come commons from all of this, R1 plus R2 plus R3 So I cancel off. We have resistance in series equals to R1 plus R2 plus R3. So whenever we have resistance in series, what happens is all the resistance gets added up. So this is the basic conclusion that we draw from our experiment over here. So whenever the resistances are connected in series like this, say one after another, without the splitting, so we say that the resistance is connected in series, and whenever resistance is connected in series, the total resistance just becomes equals to the sum of all the resistances. Okay. And number 2, resistors in parallel. So understanding both these concepts is very important here. So how does the parallel circuit looks like? This A denotes the ammeter. Resistance 1, resistance 2, resistance 3, and see the potential across these 2 points is V. So when current, see here current is what is happening with the current is that there are 3 resistors and they are splitting. So the current splits into 3 parts, I1, I2 and I3. But the potential across these 2 points is constant. So the potential is same for all of this. Here see the points are different. So as the points are different, what happens is potentials are different. And they add up to be equals to the total potential. But here what happens is the current splits and the sum of all the currents will be I1, I2 and I3 will again meet up and become total as I. So in parallel what happens is V is constant for all the resistors. I, the current, splits and is different for different resistors, and the total current I will be equals to the sum of individual currents I1 plus I2 plus I3. So now this is one of an important point. So now V equals to IR. So from here we have V by R equals to I. So I is basically equals to V by R. So this implies I will be equals to total voltage. The total current will be equals to the total voltage by the total resistance. And this resistance is in parallel. So I am mentioning this by RP. This is equals to the I1 for resistance 1 will be equals to V by R1 because the voltage is same for all of this. So this will be equals to V by R1 plus V by R2 plus V by R3. Now V by Rp equals to, V comes common, 1 by R1 plus 1 by R2 plus 1 by R3. So V and V cancels off. We have now 1 by Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3. So the resistance and parallel, when we find out, what we do is we take the sum of the reciprocal to get the reciprocal of the resistance and parallel. Okay, so for today's class we'll discuss this much, and the next class we are going to look into different examples relating them. Thank you.